Hello, is my voice clear? Mic check. Please respond if my voice is clear or not. Okay, so before we start, please type your full name. So before we start, please type your full name in the chat box and then the country that you are from. Okay, or you can use the code of your country, like from the Philippines, you can just use the PH. Okay.
Okay.
So again, please type your full name in the chat box and then the country that you are from. So I can see they are from Indonesia and others, and they're also from Vietnam, and the majority is from the Philippines. Okay, so let's start. Good morning, everyone. So I hope you have eaten your breakfast before you join the session. So for today, I think we have this warm up. I think this is the first time that we have our warm up for this HKIMO final review for this program. I think this is to refresh. This is to refresh the formulas. This is to refresh the ideas, some properties that is involved in your level. Okay, so welcome to this. I think this is what they call the warm up for the HKIMO final review, and this is for secondary 2 level. So before we proceed to the discussion proper, there are house rules that we need to follow. First is you need to mute your microphone if you do not have anything to say, and then unmute if you are asked to do so. And then be attentive and feel free to interact with the class. And then you may type in the chat for any concerns. Then do not annotate in the presentation if you're not asked to do so. So um, as we go along with the discussion, you can actually you can type your solutions if you have different solution. Okay, and you can also chat me through direct message if you have any concerns or if you have noticed some incorrections in the solution. Okay, so let's start with the first part. So for those who are not late, for those who are late, you need to type your full name and then your code or your country or the code of your country. This is to recognize who are those people that are present in this session. Okay, so let's start with the first part of this test. We have the logical thinking, and for problem 1. Okay, by the way, this warm up is just easy. So these are basic. As I have scrolled with the problems, they are just easy and they are not difficult to deal with. Okay. So problem 1, we have given A and B are two non-zero digits, and the two-digit numbers formed by these two digits have the following properties. We have AB, that is bar AB, so that means that is a two-digit number, is divisible by 9. For B, the difference between bar BA, that is a two-digit number, and a square number is 1. Find the two-digit number AB. So what do you think? So I assume that you have already answered this one because this is a warm up. So many of you, so you can actually share your answer in the chat box. Okay. So many of you answered 36. Let's see about that one. So take note that in the first condition, AB is divisible by 9. So we need to list down all the two-digit numbers that are multiples of 9. So we have here 18, 27, 36, 45, 54, 63, 72, 81, 90, and 99. Now for BA, that two-digit number BA, that is just the um, interchange of the digits. So that means that is 81, 72, 63, 54, 45, 36, 27, and 18. Okay? So in order to satisfy the second condition, in which the statement says that the difference between BA and a square number is 1, you can actually add 1 for the possible values for BA, and then find out which are square numbers, okay? Which is or are square numbers, okay? So we have here 81 plus 1, that is 82, so that is not a square number. 72 plus 1, that is 73, not a square number. 63 plus 1, that is 64, and 64 is a square number, so we can consider that one. 54 plus 1, 55, that is not a square number. 45 plus 1, 46, that is not a square number. 36 plus 1, that would be 37, that is not a square number. 27 plus 1, that is 28. That is also not a square number. And 18 plus 1, 19. That is also not a square number. So that means we only have one possible value for this. So BA is 63. Okay, and since we are asked to find the two-digit number AB, so just the interchange of the digits, that is 36. Okay, I think 99 is not possible because if you add 1, right. Okay, now if you add 1, yes, that is a square number. Correct, correct, correct. Thank you for that. Correct me if I'm not wrong. 99 plus 1, that is 100, right? 99 plus 1, that is 100, and 100 is also a perfect square number. Okay, I think yes, that is also a condition. Is A is equal to B? I think it is not mentioned in the given in the problem. So we need to stick with 63 and 99. Okay, 99 could be a possible answer for this also, and unless it's stated there that A is not equal to B, or it's stated there that given A and B are two distinct non-zero digits. Okay, so we have two possible answers for this one. Unless it's stated there that A and B are two distinct non-zero digits, or there is a statement there that A is not equal to B, then we need to stick with 63 or 36 for that answer. Okay, but then there is no statement about that, so there are two possible answer for this one. Question, or not, or none. Are there any questions, clarifications? Okay, none. So we need to proceed to problem 2. Okay, this one. Peter goes west for 23 kilometers, then goes north for 12 kilometers, and goes east for 18 kilometers. How far is he now from the original position? So in order for you to answer this one, it's better to illustrate the problem. So you can actually share your solution in the chat box, okay? If you have different solution with the solution presented in the PPT. Okay, so we have here, let's try to To illustrate, so Peter goes west for 23 kilometers. So this is the direction. And then goes north for 12 kilometers. Okay, this one goes north for 12 kilometers and goes east for 18 kilometers. Okay, this one. So we're trying to find the distance from the end point and the starting point. See, this is the end point and this is the starting point. Okay, let's try to label here another line for us to have a right triangle. Okay, so this one, this would be 23. This one, this is 12. This one, this is 18. Okay, and this one is a right triangle. So this side reflects the side of with measure 12. So we can replicate that one. Okay, and this one, how to find this, the measurement of this base of the right triangle. We're just going to subtract the whole length, which is 23, by the measurement of 18. So that means that is 23 minus 18, that would be 5. And take note that is a right triangle, so we are trying to find the hypotenuse of this figure. So we have 12 for one side and then 5 for another side. Okay, so we will be using the Pythagorean Theorem. So square root of 23 minus 18, that is the 5 squared plus the 12 squared, in order to get the hypotenuse. So square root of 5 squared, that is 25, plus 12 squared, that is 144. So that would be square root of 169, so that would be 30. Okay? Question or clarifications? I think sino yung mga nakasagot dito? So those people who got the correct answer, we have Kenzo, we have also Ngoyen, Ashanta, Velasco, Apple, May, Joshua Marie, Candice, William, Julray, and William. Okay, so those are the students who get the correct answer. Questions or clarifications? I think none, so we now proceed to problem 3. Okay, this one. If A, B, C, D, E, F plus A, B, C, D, E, F is equal to C, D, E, F, A, B, calculate A, B, C, D, E, F. So what do you think? Okay, that is not a product, okay? The variables are not multiplied to, because there is a bar. So that means that this is a 6-digit number. This is also a 6-digit number, and this is also a 6-digit number. Okay? Yes, it can be solved by trial and error, but take note that there is a pattern there. This A, B, C, D, and this A, B, and C, D, E, F. Okay, they are just switched in positions, and that would be C, D, E, F, and A, B. Okay, that means we can assume some variables there. So let's see. Okay, this one, if you try to manipulate the equation, that would be A, B, C, D, E, F times 2, because you're adding the 6-digit itself to itself. That would be is equal to C, D, E, F, A, B. Okay, and then we can assume those numbers that I have encircled there, we can assume them as variables, okay, for us not to be confused. So we can assume that X is C, D, E, F, and then Y is A, B. Okay, and so for that, this one, A, B, C, D, E, F, will be converted into Y, A, B, times 10,000 plus the C, D, E, F, X. Then copy times 2. Okay, then equals to C, D, E, F, that would be X times 100 plus A, B, that is Y. Okay, and with that, we can now simplify the equation. That would be 10,000 times Y times 2, that is 20,000 Y, then copy plus, then X times 2, that is 2X, and then copy equal sign is equal to X times 100, that is 100x plus y. And then you need to transpose those terms with the same variables. So 20,000y minus y, that would be 19,999y, is equal to 100x minus 2x, that would be 98x. Okay, and take note that 19,999 and 98 are both multiples of 7. Okay, that means we can simplify those numerical coefficient. So 19,999 divided by 7, that would be 2,857. Y is equal to 98 divided by 7, that would be 14x. That means CDEF will be 2857 and AB, that would be 14. And we are asked to find ABCDEF, that would be 14 for AB and then 2857 for CDEF. Okay, question or clarifications. You can also use the trial and error, that is also valid, but I think trial and error is time consuming. So you can master on assuming some variables to have an easier solution. Questions or clarifications? I think none. So got the correct answer. We have here Kenzo, Ashanta. We have also from Vietnam, Pham Dang, and then Nguyen, Candes, and then Krishner, and also Joshua Marie Velasco. Okay? So if there are no questions, we will now proceed to problem 4. Okay, this one, May 12th of May 2018 is Saturday. Which date of the week will 12th of May 2025 be? So what do you think is your answer for this one? May 12, 2018 is Saturday, and then which day of the week will be May 12, 2025 be? Okay, let's see. So I think most of the students answered Monday. Let's see about that one. Take note that if you move forward for 1 year, you are moving forward 1 day. Okay, take note of that one, in that same day or that same date. Okay, if you are moving 1 year forward, you are also moving 1 day forward. Let's say, for example, if 2018, May 12, 2018, that is Saturday. So May 12, 2019, that is Sunday. You are moving 1 day forward. But you need to be careful with the leap years. Because if that year is a leap year, so you are moving 2 days forward. Okay? And take note that 2020, the year 2020 is a leap year, so you will move 2 days forward. So Sunday, Monday, and then Tuesday. So that means May 12, 2020 is a Tuesday. Okay? How about 2021? 2021 is not a leap year, so move 1 day forward, that would be Wednesday. How about 2022? Move 1 day forward, Thursday. 2023, move 1 day forward, so Friday. And then 2024, that is a leap year. So you need to move 2 days forward. So Friday, Saturday, then Sunday. Okay? Now for 2025, May 12, 2025, that would be Monday. After Sunday, that is Monday. So the correct answer for this one is Monday. Question or clarifications? I think there are no questions or clarifications for this one. So we'll now proceed to problem 5. Okay, this one, there are 30 problems in a mathematics competition. The scores of each problem are allocated in the following ways. 5 marks will be given for a correct answer. 0 will be given for a blank answer or a wrong answer. Find the minimum number of candidates or candidate to ensure that 4 candidates will have the same scores in the competition. Okay, take note that you need to find how many scores are possible for a candidate to obtain. Okay, how many possible scores? So we can have a 0 if you have no correct answer, and then you can also have 5, a score of 5 if you got only one correct answer. If you have two correct answers, we have 10. If you have three correct answers, you can have 15. And if you are perfect, if you got the perfect score, so you get 30 times 5, that is 150. That means there are 31 possible scores. Okay? 31 possible scores because we need to consider the score that have no correct answer, or you got 0 for the total score. Okay? So that means there are 31 possible scores. Okay? Take note of the condition, finding the minimum number of candidates to ensure that 4 candidates will have the same score. So for the first 31 candidates, they can have a unique score because there are 31 possible scores. Okay? So there are the first 31 have a unique score. How about for the next 31? They can duplicate these scores. But take note that all of them or all of the candidates have now the same scores. Okay, only the same scores. And what we are finding here is to ensure that 4 candidates will have the same scores. Okay, so again, we need to duplicate this one. Another 31 can duplicate this score. So 31, 31, 31. That means there are 3 candidates that have the same scores. Okay, now there are 3 candidates that have the same scores. And then to ensure that there will be 4, we will just add 1. Okay, in order to have 4 same scores, the minimum number of candidates, you will need to add just only 1. So 31 for the first, 31 for the next, 31 for another 31, and then plus 1 to ensure that there are 4. So 31, 31, 31 plus 1, there would be 94. Questions or clarifications? So it's very important if you deal with this problem, or if you encounter this type of problem. So it's very important that you find how many possible scores. Okay, you find how many possible scores. That's the very first step of this solution. So I think the people who got the correct answer, we have Kenzo, Nguyen, Ashanta, Krishner, Apple, May, Julray, Joshua, Candice, William, Zach, and so on. Okay, so questions? If there are no questions or clarifications, we will now proceed to problem 6. Okay, this one. Now the light is on. Amy presses the light button 2018 to the power of 2014 times. Can you guess whether the light is on or off? What do you think? Yep, that's a very good observation from Ashanta. So the first click will be the first click that is odd, and then the second click that would be even. Okay. Since the 2018 to the power of 2014 that is even, so let's see about that one. Take note that 2018 to the power of 2014 that is even, and you divide it by 2 because you are only to guess whether it is on or off. Okay, so you just need to divide it by 2. And then the remainder is 0. That means wait, no. That means the light is still on. Okay, on. And if the remainder is odd, so that means the light is off because it is already, the light is already on. So if the remainder is 1, or if the what do you call this, the remainder is odd, if that's the logic, so that means the light is still off, or the light is off. Okay, now if the remainder is 0, because our given presses, we have 2018 to the power of 2014, and that is an even number, so that means the remainder is 0. So that is the light is still on. Okay, question or clarifications? I think most of you got the correct answer, which is on, so that's good. So if there are no questions or clarifications, we will now proceed to problem 7, or we are now in the next part, which is the algebra. Okay, this one, find the value of absolute value of x plus 901 plus square root of 902 minus y is equal to 0. This is very easy. Okay, the logic here, if you still did not know the logic here, is that take note that the operation given is plus. This one is very important. You need to take note that the operation here is plus. And there are two groups that are actually inside a sign. Like for example, we have here absolute value sign. And also here we have radical sign. Absolute value of x plus 901 plus square root of 902 minus y. And the idea, when you give an absolute value, that means the expression inside this absolute value is always positive. Okay, and also for the expression inside the radical sign, that is always positive. Okay, and there are no such thing, or there are no such solution that a positive number plus a positive number is equal to 0 unless this positive number is 0, or the expression inside the given signs are 0. So that means x plus 901 is equal to 0 and 902 minus y is equal to 0. Okay? So we can equate both equations. So x plus 901 is equal to 0. That means x is equal to negative 901. How about for the other expression? So 902 minus y is equal to 0. So that means y is equal to 902. So we are only asked to find the value of y. That means y is equal to 902. Okay, questions or clarifications? I think there are no questions, so we'll now proceed to problem 8. Okay, this one, solve x plus 2y is equal to 3, 3x minus y is equal to negative 5, find the value of y. So what do you think? So we have here, so people answered 2. Let's see about that one. Take note that this is the given, and we're trying to find the value of y. Okay, so for that, we need to have an equal numerical coefficient for the variable x for each equation. Okay, so the numerical coefficient for the first equation, or for x, variable x, should equal to the numerical coefficient for the variable x in the second equation. Okay, so that means we can just multiply the first equation by 3. Okay, in order for the two equations to have the same numerical coefficient for the variable x. Okay, so x plus 2y is equal to 3 times 3, that would be 3x, x times 3, that is 3x, plus 2y times 3, that would be 6y, is equal to 3 times 3, that would be 9. Okay, and then just copy the second equation. And with that, we can now subtract both equations in order to find the value of y. So 3x minus 3x, that is 0. 6y minus negative y, that is positive 7y. And then 9 minus negative 5, that would be 14. That means 7y is equal to 14. And y is equal to 14 divided by 7. That would be equals to 2. Okay, so that means the answer is 2. Questions or clarifications? So if none, we will now proceed to problem 9. Okay, this one, if x and y are positive integers and 3x plus 4y is equal to 33, find the minimum value of x plus y. So what do you think is the most appropriate solution for this one? Because there is no exact solution to find the values of x and y, but to trial and error, but to apply the trial and error or guess checking. Okay? It's easier for us to find the solution for x, y if we try to apply the trial and error for this problem. Okay? So that means by trial and error method, the only possible values for x, y are 3, 6, and 7, 3. Okay? And that means the minimum value of x plus y, that would be 3 plus 6, which is 9. Okay? What if I say this would be the maximum value of x, y? What do you think is the answer? Maximum value of x, y. What do you think is the maximum value? Find the maximum value of x, y. Okay, I think people already answered. Okay, so you're just going to compare the products of the two solutions. 3 times 6, that is 18, since this is x, y, so that would be x times y. So 3 times 6, that would be 18. And 7 times 3, that would be 21. And 21 is greater than 18, so that means 21 is the correct answer. Okay? I think the first one to get is Apple May Kalo. We have also Kennedy Wang, Nguyen, Rihanna, Joshua Velasco, Candice, and so on. Okay? Questions or clarifications? If none, we will now proceed to problem 10. Okay, this one, evaluate 1 plus 2 plus 3 plus so on plus 20 over 0.1 squared plus 0.2 squared plus 0.3 squared plus so on plus 1 squared. So what do you think? You can have your answer in improper fraction. You can also have that in mixed fraction, or you can also have that in decimals, as long as the decimals is not repeating. Okay, it should be terminating decimals. So let's see about that one. We have this given problem. And take note that we can actually convert the decimals into fractions. Okay? That would be 1 over 10. 0.1 is 1 over 10. 0.2 is 2 over 10. 0.3 is 3 over 10. And so on. And then 1 is just 10 over 10. So in order to have the same denominator, so we can have 10 over 10 for 1. Okay? And then with that, this would be the solution. 1 plus 2 plus 3 plus so on plus 20. It can be solved by the formula 20 times 20 plus 1, so 21 divided by 2. Okay? Over. Take note that each term are in square or are in the power of 2. So you can actually make that as one fraction. So that means the denominator is 10 squared because all of the denominators are the same. So that would be 10 squared. And then the numerator, that would be 1 squared plus 2 squared plus 3 squared plus so on plus 10 squared. Okay, and there is a formula for the sum of squares. So sino yung who are familiar with the formula for the sum of consecutive squares starting from 1? So what is that formula? Yes, correct. From William Lim, that is n squared times n plus 1 squared over 4. So, mayroon ding answer na n times n plus 1 times 2n plus 1 over 6. What is the correct answer for this? What is the sum of squares? I'll try to annotate. Oh. That would be 1 squared plus 2 squared plus 3 squared plus so on plus n squared. What do you think is the formula? Okay. So the formula for the sum of squares, that would be n times n plus 1 times 2n plus 1 over 6. Okay? So be careful with this one. This is very, what do you call this? Is very important. And also, for you not to be confused with the cubes, 1 cube plus 2 cube plus 3 cube plus so on plus n cube, that would be n squared n plus 1 squared over 4. Okay, now with this, we can use the sum of squares. This one, n times n plus 1 times 2n plus 1 all over 6, where n is the last base, that would be 10. Okay, so with that, that would be 20 over 2, that is 10 times 21, that is 210. And then you can actually reciprocate this one. So 10 squared will be in the numerator, 100. So 100 times 210 over, now for this, the solution of this, or by using the formula of the sum of squares, so we can have 10 times 10 plus 1, so 11, times 2 times 10 plus 1, so 21 all over 6. So here, 10 times 11 times 21 over 6. This would be the formula from 1 squared plus 2 squared plus 3 squared, so on, plus 10 squared. Okay? So with that, reciprocate the 6. So it will now be placed in the numerator. So 6 times 100 times 210, that would be 21,000 over 10 times 11 times 21, that is 2,310. So we have 126,000 over 2,310, or that would be 600 over 11. Okay. So what is that in mixed fraction? That is 54 and 6 over 11. So the both are accepted answers. 600 over 11 or 54 and 6 over 11 in mixed fraction. Questions or clarifications? I think none, so we now proceed to problem 11. Okay, this one, find the value of 11 cube plus 12 cube plus 13 cube plus so on plus 18 cube plus 19 cube plus 20 cube. So this is where we use the formula for the sum of cubes. Okay, but take note that the first base here started with 11. Okay, the first base started with 11, and we can only use the formula if the first base is 1, or the first term is 1 cube. Okay, that means we can use that one. Okay, by breaking down or by having a difference of the expressions, that would be 1 cube plus 2 cube plus 3 cube plus so on plus 18 cube plus 19 cube plus 20 cube. The whole expression subtracted to the expression with 1 cube plus 2 cube plus 3 cube plus so on plus 8 cube plus 9 cube plus 10 cube. Okay, so that means this expression, the original problem or from our given problem, equates to this whole or the sum of the cubes from 1 to 20 minus the sum of the cubes from 1 to 10. Okay, so this one, if you subtract this one, that is just the expression from our original problem. Okay, so we can now apply the formula for the sum of cubes, in which that would be n squared times n plus 1 squared over 4. So we can use that one. N squared times n plus 1 squared over 4. The sum of cubes. Okay? Oh, 4 pala ito. This is actually 4. Okay? So from 1 to 20, so 20 for n, 20 squared times, tama pala yung 2. It's the 2 is also correct because the square is outside the parentheses. Okay? So for you not to be confused, it can also be expressed as n times n plus 1 over 2, the whole expression raised to 2. They're just the same or equal. Okay? So n would be 20 for the first expression. So 20 times 20 plus 1, so 21 over 2 to the power of 2 minus, for the second expression, that is from 1 to 10. So that would be 10 times 10 plus 1, so 11 over 2, the whole expression raised to 2. Okay? So that would be 44,100. That is 20 times 21 over 2 to the power of 2 minus 10 times 11 over 2 to the power of 2. That is 3,025. So the difference, that would be 41,075. Question or clarifications? Just remember the formulas for the sum of squares and also remember the formula for the sum of cubes. Okay, because that is very important. So if there are no questions, we will now proceed to problem 12. Okay, this one, given a and b are positive real numbers and satisfy equations a squared plus b squared is equal to 79 and a plus b is equal to 9. Find the value of ab. What do you think? Okay, let's see about that one. So most of you answered 1. Okay, so actually we can use the a plus b to the power of 2, the whole expression to the power of 2. We can use this one, the square of a plus b, that would be a squared plus 2ab plus b squared. Okay, and as you can see, some terms there are given in the problem. So we have here a plus b, that is 9, and then here we have a squared plus b squared, that is 79. And we are trying to find, or we are asked to find the value of ab. Okay, so a plus b, that would be 9 squared is equal to a squared plus b squared, that would be 79 plus 2ab. Okay, and then you need to transpose, that would be 2ab is equal to 9 squared is 81, transpose 79, that becomes negative 79. So 2ab is equal to 2, 81 minus 79, that is 2. So ab is equal to 1. Questions or clarifications? I think most of you got the correct answer. Si Jerian got the correct answer. Nguyen, Ashanta, Rihanna, Kenzo, Apple May, Joshua, and so on. Okay. If there are no questions or clarifications, so we will now proceed to problem 13. Or we are now in the number theory part. Okay, this one, a 3-digit number has exactly 3 positive factors. Find the maximum value of this 3-digit number. So what do you think are these numbers that has exactly 3 positive factors? What do you think is this? What do you call these numbers that has exactly 3 positive numbers? Or what are these numbers that has exactly 3 positive factors? That is a square of, yes, square of prime numbers or prime squares. Square of a prime. Okay, a number that has exactly 3 positive factors are squares of prime numbers. Okay, so these are the prime numbers. So listing down all the prime numbers that when you square or when you raise it to 2, the result will be a 3-digit number. So 11 squared, that is 121. 13 squared, that is 169. 17 squared, I think, I forgot, but as long as it is 3-digit number. But 31 squared, that is 961, right? And then 37 squared, that is the next prime number to 31. So the next prime number is 37. So 37 squared, that is 1,369. And take note that 1,369 is a 4-digit number. So we will just end with 31. Okay, so that means if you square the 31, we get the maximum 3-digit number that has exactly 3 positive factors. So 31 squared, that would be 961. Questions or clarifications? So if none, we will now proceed to problem 14. Okay, this one, find the number of all positive factors of 830. So what do you think? What is the first step here? The first step is to prime factorize. Okay, we need to prime factorize the given number. So 830, that would be 2 times 5 times 83. 2, 5, 83 are all prime numbers. And the exponents are 1. Okay? In finding the number of all positive factors, so the solution would be different. The solution would be different if we are asked to find the sum of the positive factors. Okay? So if we are only asked to find the number of all positive factors, so we need to focus on the exponents. Okay? The exponent of the prime factor 2, that would be 1. The exponent of the prime factor 5, that would be 1. And the exponent of the prime factor 83, that is also 1. Okay? So we only need to focus on those exponents. Okay? So the number of positive factors, we will just add 1 to each exponents and then multiply. So 1 here plus 1, 1 here plus 1, 1 here plus 1. So 1 plus 1 times 1 plus 1 times 1 plus 1. Or that would be 2 times 2 times 2, or that would be 8. Okay? Or that would be 2 cubed. I think those people who got the correct answer, we have Ashanta, Candice, Apple, Jerian, Rihanna, Joshua, Kenzo, Jul Ray, William Lim, and Kennedy Wang, and so on. Okay, questions or clarifications. So be careful with this one. The sum of all positive factors is different from the solution in finding the number of all positive factors. Okay. So be careful with that one. So for the number of all positive factors, you only need to focus with the exponents. So let's proceed to problem 15. Okay, this one. How many simplified fraction of fractions with denominator 101 is or are there? So what do you think? Okay. So for this one, it is still important to prime factorize the denominator. Okay, prime factorize the denominator. But then take note that 101 is a prime factor itself. So it's easier for us to know the number of simplified fractions. That would be 101 minus 1. Okay, since there is only one prime factor, the prime number itself. Okay, so 101 minus 1, that is 100. So there are 100 simplified fractions with denominator 101. Questions or clarifications? So if there are no questions, so we will have our break first before we continue. So it's 9:56. So be back at 10:06. Or I think the time from other countries is different. As long as it is 10 minutes, be back at 10 minutes. You can have your bathroom break, your snack break, or anything. So are all people here? So we now continue. We can now continue to problem 16. Okay? Okay. So for problem 16, find the integral part of 1 over 2018 plus 1 over, 2 over 2018 plus 3 over 2018 plus so on plus 1006 over 2018 plus 1007 over 2018 plus 1008 over 2018. Okay, so what do you think is the answer? So people answered here 252. Let's see about that one. You can actually make this as a one fraction. This given problem, you can make it as one fraction. That would be 1 plus 2 plus 3 plus so on plus 1006 plus 1007 plus 1008 all over 2018. Okay, because all of the terms there or all of the fractions have the same denominator 2018. Okay, so with that, you can simplify, or you can now add the numerator. So that would be 1008 times 1009 divided by 2. Okay, if you are given with a sum of consecutive numbers starting from 1. So that this would be the formula 1008 times 1008 plus 1. So 1009 all over 2. Okay, take note that we can actually cancel 1009 and 2018, right? Because 2018 is just 1009 multiplied by 2. So 1009 over 2018, so that would be 2. Okay, and also 1008 divided by 2, that would be 504, right? If you cancel that one, and also 504 divided by 2, that would be 252. 1008 divided by 4, that would be 252. Questions or clarifications? I think none. So we now proceed to problem 17. Okay, this one. Find the decimal part of negative 1 over 2018 minus 2 over 2018 minus 3 over 2018 minus so on minus 9 over 2018 minus 10 over 2018. So what do you think is the answer? We are only asked to find the decimal part of this formula. Okay, so with that, given this expression, we can actually use by simplifying this as one fraction, since all of the fractions here are the same fraction. Denominator. So 2018. So you can actually get or factor out the negatives. So that would be negative. So 1 plus 2 plus 3 plus so on plus 9 plus 10 all over 2018. Okay, so that would be negative 10 times 11 over 2 over 2018. That would be negative 55 over 2018. But then we need to add 1. Okay, that would be negative 1 plus 1963 over 2018. So this would be the decimal part. 1963 over 2018. Yep, because we are finding the positive decimal part of this answer. Questions or clarifications? I think none, so we now proceed to problem 18. Okay, for this one, it is known that x is a rational and x is greater than 0 and x is equal to 3 square root of 3 square root of 3 square root of 3 and so on. Find the value of x. Okay, so you can actually observe the pattern there. you can actually observe the pattern there that it is repeating. Okay, so if you observe that in the expression there is a repeating, or there is a repeating expression, so you can actually substitute that as the whole variable. Okay, so you have this given equation, and take note that this whole expression is just the whole expression, or this particular expression is just the whole expression. So we can just substitute that as x. Okay, so that would be x is equal to 3 square root of the x. Okay, and then square both sides. We can square this one and square this one, so that would be x squared is equal to 3 squared, that is 9, then square root the square root of x, that is just x. So x squared is equal to 9x. Take note that there are two possible values for x. Okay, we can have the 0, we can also have the 9. Okay, you can have x is equal to 0 and x equals 9, but according to our problem, or according to the condition of the problem, x is greater than 0. So that means we cannot have a value of 0 for x. Okay, so x is not equal to 0. Then x is equal to 9. Okay, I think there are people who got the correct answer. We have Kenzo, Ashanta, Joshua Velasco, Julray, Krishner, Julray Alvaro, Apple May, Nguyen, and Zach. Okay, so if there are no questions, we will now proceed to problem 19. Or we are now in the geometry part. Okay, this one, it is known that the two sides adjacent to the right angle of a right angle triangle are in the ratio 1:3. If the length of the hypotenuse is 16, find the area of the triangle. So what do you think is the answer? We can actually illustrate the uh, triangle. Okay, this is actually the triangle. This is the height of the triangle, and this is the base of the triangle. And this is the hypotenuse. Okay, so we can assume that this one is x. Okay, the height is x. So in the ratio 1:3, so these are the two sides adjacent to the right angle. Okay, so if the ratio of the two sides is 1:3, that would be x and then 3x. Okay, so by that, the hypotenuse is given also, that would be 16. So with that, we can now apply the Pythagorean theorem. So take note, assume x as the one side of the triangle, then the other side would be 3x according to our ratio. So x is to 3x, that would be 1:3. Okay, so by applying the Pythagorean theorem, so x squared plus 3x squared is equal to 16 squared. Okay, so that would be x squared plus 9x squared is equal to 16 squared, that is 256. Then you can add, that would be 10x squared is equal to 256, and the x squared is 256 divided by 10, that would be 25.6. Okay, so with that, what is the formula for the area of the triangle? That is the height and the base, so x times 3x divided by 2, or 1/2 times x times 3x. Okay, so 1/2 times x times 3x is equal to, that is just 3/2, then x squared. Okay, take note that the x squared, we already got this value from our first part of the solution, that is 25.6. So you can just replace that one. 3/2 times 25.6 is equal to 38.4. Okay, questions or clarifications? So the answer is 38.4. Now, how about, so I'll give you a test. How about if this is not 1:3, that is 1:4? So what do you think is the area of the triangle? Who can give me the area of the triangle? It is known that the two sides of the adjacent to the right angle of a right angle triangle are in the ratio 1:4. If the length of the hypotenuse is 16, find the area of the triangle. So what do you think? Easy answer. You can answer it in fraction form. Who could give me the correct answer for this one? Okay, let's see. We have different answers from the people. Let's see about that one. Let's try to solve this in the presentation. So if the ratio is 1:4, that means this one is 4x. Okay, this is now 4x. So our solution would be applying the Pythagorean theorem. That would be x squared plus 4x squared, that is 16x squared, is equal to 16 squared, that is 256. Okay, so 17x squared is equal to 256. That means x squared is equal to 256 over 17. Okay, what is the area of that triangle? That is 1/2 times x, the height, and then the base, 4x. That is just 2x squared, right? 4 over 2, that is 2. And then x times x, that is x squared. And then since we already got the x squared, this is the x squared. So 2 times 256 over 17, that would be 512 over 17. So the answer is 512 over 17. Okay. I think the first one to get the correct answer is Kristner Shane. I cannot see the surnames. Kristner Shane. So she got the correct answer first. And then, okay. And also we got the correct answer from Joshua Velasco and Nguyen from Vietnam. Wow. And also Apple May. Okay. So that would be the solution for this one, if the ratio is 1:4. Question or clarifications? I think none, so we now proceed to problem 20. Okay, this one, for 4 points on a coordinate plane, point A is 2, 0, point B is 2, 4, point C is -6, 4, and then we have also point D, which is unknown. Find the area of the rectangle formed by using these 4 points as vertices. So what do you think? I think it's easier for us if we try to plot the 3 points. Okay? So what do you think is the answer for this one? I think it's easier for us to plot the 3 points first. So this would be the Cartesian plane, and point A, that is 2, 0. So this would be the 2, 0. Okay, this would be the 2, 0. And then B is 2, 4. 1, 2, 3, 4. And then C is -6, 4. So 1, 2, 3, 4, 5, 6. So that this would be the B. This would be A. This would be the B. And this would be the C. So I think it's very obvious to where we could plot the point D, right? So this is the rectangle. So it's very obvious that by connecting this line to this x-axis, so we can actually see the point D. This would be the D. Okay, or that would be -6, 0. Okay, So point D would be negative 6, 0. Okay, and by that, it's easier for us to get the area by just following the figure. So what could be the length of this figure? That would be, this length is just 8, right? 6 plus 2, 6 units plus 2 units, that is 8. And the width, that would be 4 units. Okay, so that means the area, that would be 8 times 4 is equal to 32. Yes, it's not necessary to get the point T, because it's obvious in the Cartesian plane. So questions or clarifications. I think people will get the correct answer. We have Rihanna, Jerian, Candice, Krishner, Julray, Zach, Pham from Vietnam, Apple May, and so on. We have also Nuria, Joshua Velasco, and so on. So if there are no questions, we will now proceed to problem 21. Okay, this one. In the figure below, AC is perpendicular to BD, AB is perpendicular to AD, and AD over AB is equal to square root of 3. Evaluate CD over CB. Okay, take note that AB, this line AB is perpendicular to AD. So that means this is a right triangle. Okay, so we can actually see or observe that this whole figure is a right triangle, this ABD, since AB is perpendicular to AD. Okay, so with that, we can use the Pythagorean theorem, apply the Pythagorean theorem. That would be BD squared. This is the hypotenuse of the whole figure. BD squared is equal to AD squared plus AB squared. Okay, by following the Pythagorean theorem of the whole triangle, of this whole figure. Okay, and then BD squared, take note that AD, according to our given, if you try to transpose AB, that is AD is equal to square root of 3 AB. Okay, so that means we can substitute AD as square root of 3 AB squared plus AB squared. Okay, so square root of 3 squared, that is 3. So 3AB squared plus AB squared, that is 4AB squared. So BD squared is just 4AB squared. If you try to extract radical sign there for both sides, that would be BD over 2. BD is equal to 2AB. You try to have radical sign for both sides. Square root of BD squared, that is BD. Square root of 4AB squared, that is 2AB. So BD is equal to 2AB. Okay? And then take note that ADC, wait, using this logic, where BD is 2AB, where is that? BD is 2AB. So this is AB. And this is 2AB. And this is square root of 3AB. AD is square root of 3AB. This is actually a special right triangle. Okay? If you are familiar with the special angles of the right triangle. Okay? With this idea, AB, 2AB, and then square root of 3AB. Okay? So if that is the sides of the triangle, so that means this is 30 degrees, this is 60 degrees, and this is 90 degrees. Okay, the whole figure that is a right triangle is a 30, 60, 90 right triangle. Okay, if you follow the idea or the property of a special right triangle. Okay, ADC is 30 degrees. That means BAC, take note that ACB here, that is a right triangle. This is also a right triangle. This is also a right triangle. That means if this is 60 degrees, this is also 30 degrees. Okay, so that means AB, that would be 2BC. Okay, applying the property of the special right triangle 30, 60, 90. So AB is just equal to 2BC. Okay, so that means BC is equal to 1/2 AB. If you try to transpose 2 in the other side of the equation, over 2, so BC is equal to 1/2 AB. Okay, and take note that we can now find the CD because as what is asked in our problem is CD over CB, where CB we already got the CB in terms of AB, that is 1/2 AB. So that means CD, this CD is just the whole length, which is 2AB minus BC. Okay, 2AB minus BC, whereas BC is 1/2 AB. So CD is 2AB minus 1/2 AB, or 2 minus 1/2 AB. Okay, so CD is equal to 3 over 2 AB. So with that, CD over CB, we already got the CD, we already got the CB. It can still be read as CB. So that means that is 3/2 AB over 1/2 AB. That would be 3. So how do we know that AB is equal to 2BC? By the property of the 30-60 angle, or 30-60-90 right triangle. I think some of you are still confused with that. So if this is the right triangle, so this is 60 degrees, this is 90, this is 30 degrees. Okay, so BC, if BC here is X, so that means the side length opposite to the 90 angle, so that would be 2x. Okay, and the side opposite to 60 degree, that would be square root of 3x. So that's why here, this side, or the hypotenuse of triangle ACB, is just the 2 times the base BC. Here, 2 times x, so 2 times BC. Okay. Another questions or clarifications? Be careful with that one because that is also important. The 30, 60, 90 right triangle. Okay, so if 30, 60, 90 right triangle, the side length, I mean the hypotenuse or the side length opposite to 90, that is twice the base. Okay, and the other side or the height of the triangle, which is opposite to 60 degree, that would be square root of 3 times the base x. Okay, whereas the side length opposite to 30 degree, that is just the x. Okay, so for this one, if this is BC, that means the hypotenuse BC is opposite to 30 degrees. So that means the hypotenuse, which is opposite to 90, that would be 2 times the base BC. So 2 BC. AB is equal to 2 BC. Question or clarifications? If none, we will now proceed to problem 22. Okay, this one, what is the sum of the exterior angles of a decagon, 10-sided polygon? What do you think? Yep, correct. It is always 360. The sum of exterior angles of a regular polygon is always 360. So whatever the polygon it could be, or whatever the number of sides of that polygon, the sum of the exterior angles will always be 360. Okay? Questions or clarifications? I think none. So we now proceed to problem 22. For rectangles whose side lengths are integers in centimeter and its area is 2015 centimeters squared, how many different values of perimeter can it take? So what do you think? 4, let's see about that one. So we are finding how many different values of perimeter if the area of that rectangle is 2015. Okay? So with that, we will just find how many dimensions or how many possible dimensions that will result to an area of 2015. Okay, so with that, we will just find the pair of factors of 2015. So 2015 is that would be 1 times 2015. It could also be 5 times 403. It could also be 13 times 155. It could also be 31 times 65. Okay, and those are the only possible pair of factors of 2015. How many pair of factors? We have 1, 2, 3, 4. So that means we have 4 different values of perimeter. Okay, so that means these dimensions, this is the width, this is the length, this is the width, this is the length, this is the width, this is the length, this is the width, this is the length. Yes, there are 4 possible perimeters of this with area 2015. Questions or clarifications? Yeah, you can also use the formula, the number of factors over 2. That is correct. Find the number of factors for 2015. You can use it by prime factorization. I think 2015 is 31 times 13 times 5. Yes, that is 31 times 13 times 5. So that would be, the number of factors would be 2 times 2 times 2, which is 8 divided by 2, that would be 4. Okay, take note of that one. It could be 2015 prime factorization. 5 times 13 times 31. So the exponents are 1, 1, 1. So that means the number of positive factors, that would be 1 plus 1, 1 plus 1, and then 1 plus 1. So that would be 2 times 2 times 2, that would be 8. And you need to divide it by 2. Since we are asked to find the perimeters, not the dimensions. Okay, the number of positive factors are the dimensions, and we need to divide it by 2 in order to find the possible number of perimeters. Okay, questions or clarifications? If none, we will now proceed to problem 24. Okay, this one, find the value of h in the attached figure. Show your answer as the simplified fraction if necessary. So what do you think is the value of 4h? Take note that you can actually assess or evaluate if that whole figure is a right triangle. Okay, we can assess or evaluate if this whole figure, this triangle, is a right triangle. So how do we evaluate that one? That would be 7 squared plus 24 squared, that is 25 squared. That means that is a right triangle, where the right angle is this one. Okay, we can assess by using the given sides. So 7 squared plus 24 squared is equal to 25 squared. That means this is a right triangle. Okay, and with that, we can use the area of the triangle. We can use the area of the triangle. First is, if this is the base and this is the height, the height would be 24 and the base is 7, because this is a right triangle. So you can actually rotate this one. So this would be the height, 24, and this would be the base, 7. So 1/2 times 7 times 24, or 7 times 24 over 2. Okay, this is the area of the triangle. And we can also use the another dimensions to find the area. or that would be the h, this is the height, over the base 25. Okay, so height times the base 25 over 2. We can equate both areas, so that means we can find the value of h. So that would be h is equal to 7 times 24, this is 168 over 25. Because you can cancel the 2 here. Okay, questions or clarifications? Yep, correct, from Julre Alvaro, and also from Pham, from Vietnam, and also Krishner, and also Candice. Can we use the 1 over 7 squared plus 1 over 24 squared is equal to 1 over h squared? Let's see about that one. 49 plus 1 divided 24 squared. Square root of 1 divided answer. Yes, we can also use that one. I think that is a very good observation. Okay, there is an observation here. We can use this formula 1 over 7 squared plus 1 over 24 squared is equal to 1 over h squared. Okay, take note that you can only use this formula if the whole figure is a right triangle. Okay, if the whole figure is a right triangle and h is the height of that given triangle. Okay, if this is not a right triangle, say for example, this is not a right triangle here, so that means, wait, this is not a right triangle here, that means we cannot use this formula. Okay, 1 over one side of that triangle, which is 7 squared, plus 1 over the other side, which is 24 squared. 1 over 24 squared is equal to 1 over the height with base of that side 25, so 1 over h squared. Okay, so with this one you can still derive with h is equal to 168 over 25. Okay, very good observation from, I think that is from, I don't know, well, there is no country, from Nguyen Bao Lam. I think that is from Vietnam. Okay, question or clarifications? If none, we will now proceed to problem 25. Or we are now in the combinatorics part. Okay, it is given that the total weight of 4 apples and 3 melons is 1,700 grams, and the total weight of 3 apples and 4 melons is 1,800 grams. What is the weight of 1 melon? So what do you think? So we can actually assume that the apple, or the weight of the apple, is x and the weight of the melon is y. Okay, we can assume with that one. We can assume that the weight of 1 apple is x and weight of 1 melon is y. So this would be the first statement. So for 4 apples, so 4 times x, x is the weight of 1 apple, plus 3 melons, so 3 times y is the weight of 1 melon, is equal to the total weight is 1,700 grams. Okay, for the second statement, 3 apples, so 3 times x, x is the weight of 1 apple, plus 4 melons, so 4 times y is equal to the total weight is 1,800. Okay, take note that we will use the elimination method. So how do we use the elimination method? Take note that we are finding the weight of the melon. That is the y. So we need to retain the value of or the variable y. So that means we need to cancel the x. Okay. So by that, in elimination method, we need to have an equal coefficient or numerical coefficient for the variable x. So that means this first equation, we will multiply this by 3. The second equation will multiply this by 4. Okay, so that would be 4x plus 3y is equal to 1,700 times 3. That would be 12x plus 9y is equal to 5,100. And also for the second equation, 3x plus 4y is equal to 1,800 times 4. That would be 12x plus 16y is equal to 7,200. And now subtract both equations. So 12x minus 12x, that is 0. 16y minus 9y, that is 7y. 7,200 minus 5,100, that is 2,100. So y is equal to 2,100 over 7, that would be 300. So that would be the weight of one melon. Since we assume that the variable y is the weight of one melon. Okay, questions or clarifications? I think none. We will now proceed to problem 26. Okay, this one. Find, there are 6 boys and 9 girls in a class. Choose 3 boys and 3 girls to form a discussion group. How many ways is or are there in total? So what do you think? So this one is very combination problem, and you can use the combination formula. We are choosing 3 boys from 6 boys, and we are also choosing 3 girls from the 9 girls. Okay, so with that, by using the combination formula, that would be 6 choose 3 times 9 choose 3. Okay, 6 choose 3 times 9 choose 3. So I assume that you already know how to use the combination formula. So for a recap, so I just recap n choose 3, that would, n choose r, that is n factorial over n minus r factorial times r factorial. Okay, so for recap, so do not forget that formula. So by using 6 choose 3, that would be 6 factorial, so 6 times 5 times 4 times 3 factorial, over 6 minus 3, that would be 3 factorial, and then 3 factorial, that is times 3 times 2 times 1. Okay, now you can cancel there the 3 factorial. Okay, and also for 9 choose 3, so that would be 9 factorial, so 9 times 8 times 7 times 6 factorial over 9 minus 3, so 6 factorial times 3 factorial, that would be times 3 times 2 times 1. So you can cancel the 6 factorial there. Okay, so with that, simplify. 6 times 5 times 4 divided by 3 times 2, that would be 20, times 9 times 8 times 7 divided by 3 times 2, that would be 84. So 20 times 84, that would be 1,680. Okay, questions or clarifications for this one? So do not forget the formula for the combinations, because that is very important. So if there are no questions, we will now proceed to problem 27. Okay, this one, a fair 6 die is thrown 3 times. Find the probability that the sum of numbers obtained is 17. So what do you think? Okay, so people answered 1 over 72. Let's see about that one. So we have a 6-face die that is thrown 3 times. Okay, and then the sum of the numbers should be 17. There is only one set that can have a sum of 17. That would be 566. Okay, but then there are 3 possible combinations for 566. We can have 566. You can also have 656. You can also have 665. Okay, 566, 656, and also 665. So there are 3 possible combinations. Okay, with that, the probability is equal to 3. That is the possible combinations. 3 over 6 cubed. The total combination can be solved by 6 times 6 times 6, because you are throwing that 6-face die 3 times. So 3 over 6 cubed, or that would be 3 over 216. Or that would be, in lowest term, that is 1 over 72. Questions or clarifications? I think people got the correct answer. We have Ashanta, Jerian, Apple May, Rihanna, Julray, Zach, Pam, and so on. Okay, so if there are no questions, we will now proceed to problem 28. Okay, this one, I think there is a correction there in the Solman or solution manual or in the questionnaire. That should be Andy has $20. Okay, this should be $20 and $10 banknotes. $20 and $10 banknotes. All together, he has $420 in total. How many $10 banknote or banknotes does he have? It should be $20 and $10. I think in the questionnaire that is $10 and $10. Okay, so with that we can assume some variables. X is the number of $20 and Y is the number of $10 banknotes. Okay, so X is for $20 and Y is for $10. So the total number of banknotes, we have 29. So if you add X plus Y, that would be 29. Okay, now for the total coins or total cost, or what do you call that, price or etc., that would be 20 times X. So $20 for X, 20 times X plus $10 for Y. 10Y is equal to 420. Okay, so with that, we will now use the elimination method since we have two equations with two variables. Okay, so we need to multiply the first equation by 20. Okay, the $10 banknote or the number of $10 banknote is assumed as the variable Y. So we need to retain the variable Y. Okay, so that means we need to cancel or eliminate the variable X. So that means we need to multiply this equation by 20. So X times 20, 20X, Y times 20, 20Y, 29 times 20, that is 580. So with that, by subtracting the two equations, 20x minus 20x, that is 0, 20y minus 10y, that is 10y, and then 580 minus 420, that is 160. So y is equal to 16. So that means there are 16 $10 banknotes. Questions or clarifications? I think none, so we now proceed to problem 29. Okay, this one, inside the 52 card poker, 2 cards are chosen. Find the probability that the sum of numbers obtained is 17. Okay, Jack, the Jack card can be expressed as 11, or it should be considered as 11, and then the Queen should be considered as 12, and then the King should be considered as 13. Okay, so what could be the possible cards that has a sum of 17? So we have here, this is the possible pair of cards. So we have here 4 plus 13, that one. We can also have 5 plus 12. We can also have 6 plus 11. You can also have 7 plus 10, and then also 8 plus 9. Okay, take note that 13 is the maximum number for that cards. Okay, so we have how many possible pairs? We have 1, 2, 3, 4, 5. Okay, but take note that they can still be interchanged. So 413 is different from 13.4. 512 is different from 12.5. 611 is different from 11.6. 710 is also different from 10.7. And 8.9 is also different from 9.8. So that means there are 10 possible combinations. That would be 5 possible pairs times 2. That would be 10 possible combinations. Okay? So with that, this would be the given problem. But take note that there are 4 elements of the cards in that deck of card. There is clubs, there is There is hearts, there is diamonds, and then we have also ace. I mean the spades. I mean the spades, the clubs, the hearts, and the diamonds. Okay, so we are still choosing those numbers from those four elements. Okay, so the first card we have 4, since there are 4 elements, over 52 for the total number of poker card, times another 4 for the elements over, since we already got to pick one card, so that means there are 51 remaining cards. So 4 over 51 times the possible combinations, which is 10. So 4 over 52 times 4 over 51 times 10, that would be 40 over 663. Questions or clarifications? Baka may questions. Are there any questions or clarifications for this one? Just take note that in a card there are 4 elements. Okay, so be careful with that one. So if there are no questions or clarifications, we are now in the last problem. Okay, this one, there are 47 students in grade 8, 27 and 25 students like playing basketball and volleyball, respectively. However, we don't know the number of students who like both ball games. Find the maximum number of students who don't like both ball games. Okay, so how do we find this one? How do we find the answer for this one? To find the maximum students who don't like both ball games, so the students who like volleyball should also like basketball. Okay, take note of the compare the number of students. 27 is greater than 25. That means we can absorb the lesser students from the greater number of students. Okay, how do we observe that one? So if I'll try to use a Venn diagram, this is the Venn diagram. So by absorbing, this would be those who like basketball, and this would be those who like volleyball. Okay, so by absorbing the volleyball, those who like volleyball, because it has a lesser students, so that means we will consider that as those who like both ball games. Okay, the students who like volleyball should also like the basketball. So that means those 25 likes, or those 25 students like both ball games. Okay, so that means the number of students here, we have only 2, because there are 27 students who like playing the basketball. Okay, hence there are 27 students who like both games and 2 students who like basketball only. Okay, and this is also possible because we don't know the number of students who like both ball games. Okay, so with that, the number of students who don't like both, so those students that is outside this Venn diagram, so that would be 47 minus 2 minus 25, or that would be 47 minus 27, so that would be 20. Okay, questions or clarifications? So I think none. If there are no questions or clarifications, so thank you for attending the meeting and session. So good luck for your exam. Okay, so you may now leave the meeting. If there are 2 distinct answers that are both correct in a question, how do we answer those? Like question 1 and 3. If you think, if you are really sure that there are 2 distinct answers, you can actually answer that by giving the 2 by giving out the two answers. Okay, if you are really sure that there are two distinct answers for a particular problem, like for example, like we have the case from the question one of the problem one. If you're really sure, you can give out the two answers that you derive. Okay, but if you are not really sure, just choose the safest option. Okay, I think that would be all. Thank you for attending.